Hello friends, welcome to my channel. Let's have a look at problem 2592. Maximize greatness of an array. In this video, we're going to share a solution based on the two-pointer method or just a for loop. In this problem, we are given a zero-indexed integer array called nums. We are allowed to commute nums into a new array perm of our choice. So we define the greatness of nums to be the number of indices for which perm I is strictly larger than nums I. So we are required to return the maximum possible greatness we can achieve after the permutation. So here are two examples. Example 2 is special because the list is in sorted order. It's relatively easier to analyze, right? So we can align this original nums with 2, 3, 4, 1. Then there are 3 positions corresponding to larger elements, so we return 3. The first example, the nums is not in sorted order. However, here in the explanation, it gives a possible rearrangement. So it's corresponding to the maximal greatness 4. We're going to give some details. However, we analyze the result after doing the sorting. So the constraints for this problem here are the following. I'm going to focus on the first one, that is the problem size. So the list nums can be as long as 10 to the power 5, right? The second is not that essential. So with that said, we are ready to do the analysis. So for the analysis, we're going to use sort, and then we are going to use some greedy idea. So here the key observation is that we could sort the array and then try to align each element in the array with the smallest larger elements in the array if possible, right? So this provides a strategy. So here the things are relative. So this maybe it needs some time to digest. Permuting the array and then comparing the resulted array with the original one is the same essentially in effect as the above key observation would see. Here are some walkthroughs. Here let me walk through the first example, right? After we doing the sorting, so this is the result. And then we can find that at index 2 we have 2, right? 2 is larger than the 1 in index 0. And 3 at index 4, so it's larger than the 1 in index 1. And 3 at index 5 is larger than the 1 at index 2. Similarly, 5 at index 6 is larger than 2 at index 3. So there are 4 indices. Therefore, the return is 4 for this example. So in the second example, this is a test case for this problem. And we make it already in sorted order. So here are the arrangement and the corresponding comparisons. So there are 6 lines. Therefore, the output is 6 for this example. So as for the implementation, we could do linear scan. We could do linear scan directly, or we can first count unique elements and their frequencies, then do the scan. So the latter actually complicates the problem a little bit, but I would say that can be more near or touches the core in a sense. So but in order to for the purpose of practice, we also share the second formats, I would say. With that said, first let's do version 1. So this is essentially a two-pointer method, I would say. So or you can just see a for loop. The for loop is actually for this kind of thing. You can see it's a rearrangement or it's a comparison. So what I'm going to do is that first I'm going to do a sort in place. So this, if we do not pass some arguments or sorting key, so this sorts nums in place from small to larger. And then we're going to use a left pointer. Let's see, this is the index, right? And then we're going to iterate over over the elements in nums. But in order to print some information, I'm going to use right, just to emphasize that this is a two-pointer method for right and y. The right is the index. You can understand it as the right pointer, and y is the corresponding element in enumerate nums. Then we want to find the first element that is larger than the element at the index left, and then we increment the result by 1. Let me set this one, okay. And then we are going to check if y is greater than nums at left. If so, means that for the first element we find one element that is larger. Then we are going to set the next. So we are going to set from small to larger. This is the most optimal one, right? And then after this, so that's basically all the whole body. Then we're going to return left. The left also, because of the way we wrote the code, it's also the counting or the greatness. So if we compare this if and the for loop here, it exactly corresponds to the definition of greatness. And then we can do a check before we make comments. Right. Invalid syntax error where, let's see, for invalid non-printable character. Let's see here. Here we have something. Let me. Okay, hopefully it will look good. All right. Yeah. It passes the first example. Now let's look at generic case. Yeah, it passes all the test cases. So here, if we want to just for this problem, solving this purpose, we can just do this for y in nums, and then we can comment out this line. So you can see it passes all the cases. Here, the reason I'm going to put this one. On one hand, we emphasize this is the two-point method. Another thing is that let me print something out. Print. So see element. Let's see y at index right is larger than nums left at index left. Then you are going to get the details for this reset, right? So or comparison. So this gives us 4. Similarly, you can check this example. For example, you can do this. Right, so you're going to get 6. So this way we finished the first version of the solution. So now I'm going to copy this part, the function signature, and then I want to present another solution. So I'm going to rename this one as version v1. And then what we're going to do is that, so there's a possibility that there are a lot of repetitions in the nums list. Then this way we can use frequency element and frequency to counting to reduce length, right? This actually complicates the problem. So this complicates the problem. However, in some sense, it approaches something essential, I would say, because here we are doing the coding or video for practice and for improving coding skills. I'm going to write this here. It's actually enjoyable to analyze the code and digest the code. For this purpose, first I'm going to initialize a result. So this is the same as above. I'm going to return the final state of this result. And then I'm going to make some preparation, right? So here what I'm going to do is to, first I'm going to use a dictionary to get the unique elements and their countings. So I'm going to use a counter object, which is a subclass of the Python dictionary, right? So I'm going to count this one. This will give us unique elements and their frequencies. And then what I'm going to do, I'm not going to iterate over nums. This array can be very long sometimes if there are lots of repeated elements. So what I'm going to do is to make it a tuple, let's say, a list of tuples, the element and their frequencies. So for y, frequency in d atoms. So, for now, d is a dictionary, because this assignment, we first implement the right side of this assignment symbol, right? So after we do this, we assign it as a d. Then we can do sorting, right? So this way, we sort this d according to mainly the first element. Then if there's time, we're going to sort according to frequency. Actually, that's not essential, right? So we're only caring about sorting the unique elements from small to larger. And then we're going to do the sim2 pointer, or you can see a for loop as the first solution. So here we're going to take a consideration of previous element and the current element, because after we do the sort, the later same unique elements is strictly larger than the previous one. So we're going to make some set. The previous is 0, so this is the counting for frequency, the previous smaller number, because we're just starting, so the previous is set to be 0. And then we're going to iterate. So for y previous frequency in d. So notice that we need to write d here, because d is a list of tuples now. And then first we're going to check if previous is 0, equals to 0. And in this case, so we're going to do previous equals frequency, just to reset, because it means that we are visiting the first element. So otherwise, what we're going to do, so the current y we're seeing appears this number of times. So the previous small number appears this number of times. Therefore, we can pick we need to pick the smaller one of previous and the current frequency. Let me first write n larger, right? Because mean previous and the frequency. It means that we can use this number of the current y, that is larger than the previous smaller number, right? So let me write some remark. So n larger a number of current elements, right? So we can arrange to make this number of current elements to be larger than the previous smaller numbers. So this way, the effect is that we can increment the greatness or result variable by this n larger, right? So notice that there how many elements get involved. So here, the number of elements involved is previous plus frequency. However, this number of elements are set. So we're going to reset previous to be previous plus frequency, and then minus this n larger, right? So this way, after we do the for loop, so we can return the result state. So this forms another solution format. So I guess before we make comments, let's first do a check. Yeah, it passes this example. Now let's look at the first example also. Yeah, it passes the first example. Now let's look at the generic case. Yeah, I guess it passes all the cases. So here, the previous plus frequency is the numbers involved in this. When we look at this number y, right? Then we need to minus the number of elements that are set to be smaller. Then this is the number we need to use for the next round of previous. So with that said, I guess in this video we provide a solution to this interesting problem using two-pointer method. So, or you can interpret it as a simple while loop if you can implicitly digest the logic. So the first example, the first version is the solution, or maybe one of the solutions to the problem. Here, the second one, I would say, the coding is simplifying the problem. However, this understanding is also useful. Yeah. So with that said, I guess that's about it for this video. Thank you.